Okay, so let's look at the strategy design pattern. So strategy design pattern is within a class of patterns that we call behavioral patterns. So it's a way to have some sort of behavior in our system. So the intent of it is says to define a family of algorithms, encapsulate each one, and make them interchangeable. So basically, it's about algorithms that we have one recipe for doing something, and they are kind of similar, these kind of algorithms, so we can kind of put them under one same interface or something like that, or same superclass, so that we can encapsulate them this way. And it makes it very easy to change the strategy that we use. We can capture the abstraction in an interface, and then we can then bury the implementation in derived classes. So the idea is that we're going to work up against an interface, and that lowers the coupling to the actual way that things are done. So basically, we are moving from compile time to runtime, and I'll try to explain more about that later. So for example, here is an example of an abstraction here. So the client is using some kind of interface, and then there are two different implementations of the interface. So in implementation 1 has one method do something, implementation 2 has one method do something. So basically, the only thing the client needs to know about is the interface. It doesn't need to know how the interface is implemented. This makes it easy to change out the implementation because we only know about the interface. We only know, in this case, about this single method here. So basically, the strategy pattern is an elaborate version of this one. So this is what it looks like. So we have a client. The client has some kind of context. The context has an interface that then can run an algorithm into different implementations. So I think one example of this could be, for example, encryption. Let's say we had something to encrypt. We could say encrypt and then a text as a parameter to the algorithm. And then we could have one encryption algorithm here and another one here. And basically, we can then choose which one inside of context we can choose. Are we going to use implementation 1 or implementation 2? But the client doesn't need to know anything about implementation, but it only needs to know about this context class. So this way we are decoupling the client from all the implementations, making it very easy to add more. If it's encryption, we can add more encryption algorithms in the future. If we want to do that, we just add them here, and we don't need to change anything. This is kind of the idea. We don't need to change anything else in our system because this is kind of like a closed system. So we have nice cohesion and we have a low coupling between things, and this is what we want. So here is an example called transportation to airport, and then you can choose different ways of doing it. Taxi, city bus, personal car, right? Kind of like a bit of an odd example because this is not like software, but it kind of gets the idea. So the transportation to airport means that it holds different strategies and we can choose between each one of them. But the end goal is the same. We'll get somewhere that we want to go. It might be different in terms of speed, just like if we are talking about encryption algorithms, some might be faster, some might be more secure. Same thing here, some might be faster, some might be more secure. So these are the concrete strategies for getting to from A to B, and here you might need to even to walk a bit afterwards or something like that. So first we need to identify an algorithm, that means behavior that the client would prefer access through a flex point, right? So that means the strategy. And then specify the signature in an interface. That's the strategy interface here. So kind of needs to have the same signature, meaning it needs to have the same methods here as in everyone. So if we have different algorithms with different inputs, we cannot use this directly like that. It needs to have the same interface here. And then we bury the implementation in derived classes, meaning this is where the fun happens. And the clients of the algorithm couples themselves to the interface. So yeah, that's basically it. So let's try to look at an example I made some while ago. So inside of my GitHub repository, I actually have something called design patterns examples that you might want to check out, where I have like a ton of patterns here. And one of them that I have in here is actually the strategy pattern. So let's try to open that up here. So I also try to put it like this so we can still remember how we were supposed to implement this. This implementation is a bit more advanced than the one we see here, but I'll try to explain. So this is what we are doing. I'm not going to the airport, and I'm not trying to make any encryption algorithms here, but what I'm trying to do is something called text decoration. So I'm basically making a class that I can use for decorating text in different ways. So the ways that I want to decorate the text, I want it to be like all caps. And then there's one called alt caps. It might even be hard to see here. ALT caps. So it's one caps, not caps, caps, not caps, and so forth. And then there's wide spacing, where I basically add a space between each letter. And then I have something called text decorator, and I have something called strategy pattern test. And strategy pattern test is just the main method that I made for testing out the pattern. So let me show you how I can use it. So I have a text saying all Kanis are evil. And interestingly enough, I think it says that all Banis are evil. I must have made a mistake there. It's kind of weird. All Banis are evil. I'm not sure. I'll go back to my Kanis. So doesn't matter, I have some input text here. Then I say text decoration strategy, caps strategy, new text decoration strategy, all caps. So the interesting thing to note here is that text decoration strategy, there's an I here, meaning this is an interface. So if I open up the interface, you will see it's very simple. It has one method. You say decorate text, give the text as the input, and then get back another text as output. So what I do here is I use this, which is very importantly the interface, this one. The interface, I say cap strategy, and then I say new text decoration strategy, all caps. So here I'm actually saying I want a cap strategy, but it's this one. All decoration strategy, all caps. So it will be all caps. And then I apply that here to my text and print it out. And then I do that again and again. If we see it running, it will take some time. My computer here is a bit slow. If we see it running, we'll see the different kinds of system outs for the different strategies here. So we can see it says all Kanis are evil. This is all caps. And then the other one is applies deco wide. So it does wide here. And then I have a special version for you here where I kind of double apply the strategies and so forth. So this way we can change the text. This is the alt caps version here. So this is basically what's going on. I have the context. If we look here, which is this one in here, and then we say text decoration cap strategy. Then I use the text decorator. Let's look here. So the text decorator is the context in this case, right? So context here, and then we have the interface, this one here, and then we have these, which are the implementations, which are just some simple code in here. So this one will use the decorator to do that. I kind of expanded a bit upon this because in this version you can see it has this thing here. So it actually means that we could have more than one strategy in here. So I actually made it so that the text decorator, which is my context, can hold more than one strategy. So I can actually add multiple strategies. So I can give this array of text decoration strategies, and then I can supply that so it will use multiple strategies at once. So for example here, let me show you. So here I say new text decorator, and I actually add multiple strategies here at the same time. So that means the last one is going to be using both white space strategy and all caps strategy. It uses both of them. Doesn't look like it's working though. I'm not sure what's going on, but it doesn't really matter. The idea is that that we can have like multiple strategies that we connect to the context, so we can have multiple of these algorithms working at the same time onto this, or one after the other, or however you want to do it. So it's kind of a bit of an advancement of the original, I think. So just to sum it up, so what would be the difference if I didn't use this strategy? So if I didn't use this strategy or the strategy pattern, what I couldn't do is I could not connect it to the context like that. So that would mean that the client who would call the deco class would need to know about all of this stuff here. In this case, though, it's a bit weird because it still knows about it. I need to say new text decoration strategy, all caps. I could couple this with a factory pattern as well, and then I could get out of this, but I think this is out of scope for this video. But we could do something like that so that the main method here would know nothing about that. Maybe just send an enum or something that says I want this strategy or that strategy or something like that, and then encapsulate everything inside of the context. But I hope this kind of shows an example of what you can do with the strategy pattern, and there's like tons of ways. But generally you do it when you have multiple implementations of an algorithm that has the same signature here. You can do that. So it's basically an advanced version of an interface, use of an interface. Generally, this is a pattern I've seen used a lot. It's a very well known and very used pattern because it's very simple. It's very close to, you know, just using an interface or indirection in general. So it's like a general way of doing decoupling between classes. So a nice pattern. That's it for the strategy pattern.